So now we are going to learn the AC amplifier. So where this AC amplifier is going to be used? When we want to amplify a pure AC signal, that is without any DC. Always AC will be combined with DC. General ga chodandi. So this is your DC signal. Idi DC. And this is a pure AC and this is DC. So AC and DC will be combinedly sent. But if you want to remove this DC and you want only AC for some special applications, if you want to find AC frequency response, then you have to block DC. So the circuit which is dealing with AC only is called AC amplifier. Dealing with only AC is called AC amplifier. And we know that a capacitor will block DC. So what I have to do? I have to take either non-inverting or inverting op amp, and I have to place a capacitor in front of R1. In front of R1. So what does it leads to? If a capacitor is facing us, then it is nothing but a high pass filter. High pass filter frequency will be decided by this R1 and C. So which is called as a time constant. Reciprocal of time constant will give the frequency. So if a capacitor is connected here, then DC will be blocked and a pure AC will be traveling. So now I am dealing with AC amplifier in inverting mode as well as non-inverting mode also. So this is the modification of non-inverting mode op amp. Here, first, we are talking that this is nothing but a high pass filter. So high pass filter is a filter. High pass filter is a filter which will pass all the frequencies which are after a corner frequency or threshold frequency or a cutoff frequency which is called FH. So up to the frequency FH, all the signals will be blocked, and from FH, after the FH, all the signals will be passed. When compared with this, lower region is blocked and upper region is transmitted. That is the reason it is called high frequency amplifier and a high pass amplifier. అంటే high frequencies మాత్రమే amplify చేస్తారు. So here this is the frequency response of my high pass amplifier. High signals మాత్రమే pass చేస్తారు. So if I want to find what is the cutoff frequency or corner frequency which will decide the lower dB, lower 3 dB. అంటే ఏంటి, ఇక్కడికి వచ్చేటప్పటికి ఇలా కట్ అవుతా ఫ్రీక్వెన్సీస్ వస్తాయి. సో ఇది 3 dB మైనస్ 3 dB అంటే లోవర్ 3 dBని డిసైడ్ చేస్తారు. సో FH will decide my corner frequency which is at the lower side of the frequency response. So to find that corner frequency, what I have to do now, it is an inverting op amp. So signal is given to inverting input terminal, a capacitor is placed here and all other circuit is as it is, and this is grounded. So if it is at ground, this also will be at ground. So the voltage at this junction is going to be 0 volts. So what is my V0? V0 is equal to, I am showing the current in this direction. Actually current will flow in this direction. So what happens? My V0 will be minus I into RF. minus I into RF. What is I? The same current which is flowing from this will go through this. So what is my I? I is going to be VI minus 0. So VI by R1 plus 1 by j omega C. R1 plus 1 by j omega C. That is the resistance voltage difference divided by total resistance. So here resistor will have a resistance, capacitor will have a resistance which is called reactance. That reactance is going to be 1 by j omega C into RF. So what is my gain? Gain is going to be V0 by VI is equal to RF by, ఇక్కడ ఏం చేస్తాను నేను LCM కడితే j omega C R1 plus 1 by j omega C. So this will become RF into j omega C divided by 1 plus j omega C R1. Now, so omega can be written as 2 pi f. Omega can be written as 2 pi f. So, omega can be written as 2 pi f. So, my gain V0 by Vi is equal to RF, minus is there. So, you have to keep minus also. Minus petali. So, minus RF into j omega C divided by 1 plus j into 2 pi f R1C. Now, if I take FH is equal to 1 by 2 pi R1C and తీసుకుంటే, then what will be 2 pi R1C is equal to 1 by FH. I can write. So lower side kabatti lower cutoff frequency and పెట్టుకుందాం, not higher cutoff frequency. Lower cutoff frequency and పెట్టుకోవాలి. So lower side will be lower cutoff frequency. So sorry, higher cutoff frequency kaadu, lower cutoff frequency, lower 3 dBm. So here, so 2 pi R1C is equal to 1 by FL. So 1 by 2 pi R1C బదులు FL రాసుకోవచ్చు. So 1 by FL బదులు 2 pi R1C బదులు 1 by FL రాసుకుంటే, my gain will be minus RF into j omega C divided by 1 plus j into F అలాగే ఉండి 2 pi R1C బదులు 1 by FL పెట్టుకుంటాం. So this is called the corner frequency, lower cutoff frequency. Up to that point the all frequencies are blocked. After that point all frequencies are passed. AC components will be passed. So this is the gain equation of this inverting op-amp, AC amplifier using inverting op-amp. Next we go for the non-inverting op-amp AC amplifier. So non-inverting op-amp should have input at the non-inverting input terminal. So the same input is here, but extra and feedback is given to as it is to the inverting terminal. Inverting terminal ఈ negative terminal ke feedback ఇవ్వాలి. ఎందుకని? Because it is a negative feedback amplifier. అది మాత్రం మారొద్దు. So ఇక negative terminal ke feedback ఇచ్చారు. So here for this, after C1, one resistor is added for the non-inverting terminal, and this is grounded. Why this resistor is added means to ground to make a path for DC to ground. DC మొత్తం గ్రౌండ్కి వెళ్ళటానికి ఒక పాత్ ఫామ్ చేయడానికి R2 resistor is used. If you use any resistor, any finite resistor at the input loop, this will decide your input impedance. And because to make it ground, R2 should be less. అంతే కదా, రెసిస్టెన్స్ వాల్యూ తక్కువ ఉండాలి. తక్కువ ఉన్నప్పుడు ఏమవుతుంది, all DC will be comfortably grounded. But if the R2 is less, input impedance of your op amp is going to be less. So this is not a tolerable thing. So input impedance of any electronic circuit should be as high as possible. So this is having a this is the modified version of this non-inverting op amp. Here what we have done is, in the feedback bath we have connected a capacitor C3, and such that we placed or selected all these values in such a way that the potential at this point and the potential at this point are almost same. So if these two are at the same potential, then no current will flow through this. If no current is flowing through this, this will be acting as a open circuit. So if it is acting as a open circuit, input impedance will be large. So my purpose, all the DCs are going to be grounded and my input impedance is considered as high as possible. And here a very large value of C3 is used, and this C3 will be shorted for all high frequency signals, AC signals. So this will act as a short circuit, and so no problem for the transmission of the or flow of the signals in the feedback path. So this is the non-inverting model of AC amplifier.